In this lesson, we're going to be talking about the VLAN Trunking Protocol, specifically VTP version 1 and VTP version 2. This, again, is not really a very technical discussion, but it is still considered to be one of those core technologies that you need to understand with regard to the CCIE, particularly the troubleshooting portion, not so much the config portion, although you do need to make sure and verify that the layer 2 forwarding domain is working in the config and the troubleshooting portion and the config portion. But again, VTP is an administrative function. It's not really VTP does not determine how the broadcast domain works or does not determine how my forwarding plane works. It just allows me to propagate information. So the VLAN Trunking Protocol, which is Cisco proprietary, it's a layer 2 protocol, allows us to reduce the administration that exists in a switch network. When I configure a new VLAN on a VTP server happens to be the default mode of operation. If the domain is configured correctly, then that VLAN information gets distributed to all the switches within the domain. And I'm going to demonstrate this, and we'll talk about a lot of the caveats and a lot of the things that you guys need to be concerned with when it comes to dealing with VTP. But, you know, obviously these are going to be things to consider, all right? What this allows us is a reduced time and need to configure the same VLAN physically on every switch. VTP is Cisco proprietary, and it is available on most Cisco Catalyst products, but there is some limitation on the enhanced version of VTP, which is VTP version 3. Now, actually, VTP version 3 is complex enough that we kind of break out VTP version 3 in its own discussion, and we'll talk about that in our next lesson this coming week. All right? So this particular topic does not cover VTP version 3. Version 3 vastly different than version 1 and version 2, and it's only available on certain switches that are running Catalyst OS, I think 8.1 or more, and some of the XE software platforms. There are lots and lots of changes in version 3 from version 1 and version 2. So our primary focus is going to be in this lesson talking about VTP version 1 and 2. You need to definitely understand the differences between the different versions. For the written exam, you obviously you're not going to be really truly tested on the differences within the lab exam itself. All right? So we'll go ahead and take a look at that a little bit later on as part of the process. With regard to VTP, I'm going to give you a little backstory here. It's not that the backstory is necessary for the lab, but I think it's really important to understand some of the terminology and some of the functionality from a theoretical standpoint before you can truly understand the impact that it has on your network itself. So I want to give you guys a little bit of backstory about VTP, and then we'll get into some of the configuration. VTP only runs over trunk interfaces. All right, they can be sent over interswitch link or ISL, or they can be sent over .1Q frames. All right, these VTP frames are actually sent to a specific MAC address using 802.3 Ethernet, not Ethernet 2, but 802.3 Ethernet with a snap header type of 2003. And we don't really need to get into the differences between Ethernet 2 and 802.3. A snap header, which is called the Subnetwork Access Protocol, that's part of the logical link control code that allows us to identify essentially the type of protocol this is. Just like in Ethernet 2, we have a type field, which allows us to identify what's encapsulated in the frame. In 802.3 Ethernet, we have a type field as well. Now, the MAC address that's used for VTP is, let me think, 01000C, and then all C's after that, right? So CC, CC, CC. Those are that's the MAC address that's used as the destination address for these particular frames. The format of a VTP packet is fairly straightforward. You've got your Ethernet header, you got your logical link control header, your snap header, And then within the VTP frame itself, the payload, the VTP payload, you've got your VTP header, and then you've got something called a VTP message. All right? The message types are kind of important because the message types will determine how VTP functions through the network. All right? We're going to talk about things like server mode and client mode and transparent mode and what's the effect of having those different modes on our network as we go through the lab portion of this discussion, or the configuration portion of this discussion. We can put VTP, in fact, in most cases, it's going to be put inside of a .1Q frame, but it looks essentially the same as it does within an ISL frame. Let's take a look at, or talk about, I should say, the detail of a VTP packet. Because the format of a VTP header can change based on the type of VTP message that you're going to have. And there's different types of VTP messages, and I'll try to demonstrate where we might see those types of messages as part of the process. Even though we're focused on preparing you guys for the lab, I know that you guys also have to do the written at some point. So it's important to kind of talk about some of these theoretical concepts when we deal with VTP. We don't necessarily have a slide deck that matches up with this, but that's okay. All right? There are several fields within a VTP. Number one would be the first part of a VTP header would be the protocol version. Makes sense. Am I running VTP version 1? Am I running VTP version 2 or version 3? And we can actually see by using pretty much the de facto standard for verifying VTP operations, we can see what version of VTP we're running by doing a show VTP status. There are some other VTP verification commands that are available, but I can see that this particular switch is capable of running versions 1 through 3, but it's presently running version 1. Well, that information is being propagated through the VTP header itself. Just like any other protocol, EIGRP, OSPF, BGP, all of these protocols have protocol-specific headers, and then they have payload information that they carry inside of those headers. All right? Now, the other thing that we have to identify is what is the type of message that we have in VTP. Is it a summary advertisement? Is it a subset advertisement? Is it an advertisement request? Is it a VTP join message, and so on? So we have several different VTP message types that exist throughout the process of establishing the domain and then also exchanging information within that domain as well. And I'll get into some of the details of what those messages might include before we get into the configuration. The other things that are in the header, the management domain length, the management domain name, which is case sensitive. All right, we can see that domain name here. The default domain name in VTP is null, N-U-L-L, meaning that it's not configured. That's actually a very important consideration because a switch will automatically join the first domain that it sees if it doesn't have a domain configured. Once the domain is configured, it can only be manually changed. And you can't set it back to null. You have to delete the VLAN.dat or the VTP configuration in the VLAN.dat. So once the domain name is set, it can only be manually altered. But if the domain is not configured, if the domain name is null, the switch will actually just join whatever domain it sees first. This is the default behavior of VTP. All right. We also see the configuration revision number listed here. There are 16 VLANs existing in this switch. Now, the configuration revision number has not gone up. Oh, it would have normally, but it hasn't gone up because the switch isn't a member of a domain. Every time, that configuration revision number is a 32-bit number. And the purpose of that revision number is to indicate the level of revision for a particular VTP packet. Every VTP device in the topology tracks the VTP configuration revision number that is assigned to it. And most of the VTP packets contain that VTP configuration revision number of the sender. And that information is actually then used to determine whether or not the received information is more recent than the current version of database that I have presently. All right, so every time you make a change to the VTP domain, on the device, it could be adding a VLAN, deleting a VLAN, renaming a VLAN, whatever, that configuration revision number gets incremented by 1. All right. Now, once the domain name is set, and I don't want to quite demonstrate this just yet, but I will in a little bit. Once the domain name is set, that revision number will continue to increment. There's no way to reset the revision number manually. The only way you can reset the revision number is to change the domain name, which automatically resets the revision number back to 0, and then change it back to the original name, or change the mode from server or client to transparent, and then change it back to server or client. All right. We would often do this, by the way, if we're placing a switch into the network and we don't want that switch to overwrite the rest of our database. We would want to make sure that that revision number is fairly low, right? Hopefully 0, but fairly low. So change the domain name, change it back, or change the switch into transparent mode, or and then change it back to whatever default mode, the server mode or the client mode. By default, let's talk about the different types of advertisements. First of all, summary advertisement. All right. Cat switches issue summary advertisements in 5-minute increments. That's the standard periodic timer that VTP uses. So every 5 minutes, we're sending out these summary advertisements. It's kind of like, if you will, a paranoid update that you see in OSPF. Every 30 minutes, we flood out our OSPF database. The summary advertisement just allows us to inform all the other adjacent switches of the domain name, the configuration revision number, and so on. Hopefully we're already synchronized at this point, but just in case, we're sending out these summary advertisements. Now, we can also send triggered updates. In fact, that's what the switch does. If for some reason the domain has changed somehow, we add a VLAN, delete a VLAN, rename a VLAN, or whatever, we don't have to wait till that 5-minute cycle to expire before that VTP information gets propagated. All right? When a switch receives a summary advertisement, the switch compares the domain name to its own domain name. The domain names are case sensitive, so we have to match not only the name but the case. If the name is different, the switch is just basically going to ignore that particular packet. If the name is the same, the switch is then going to compare the configuration revision that it received in the summary advertisement to its own revision. If my value is higher, I'm the receiving switch. If I'm running revision 12 and I receive a summary advertisement that is revision 10, then I simply ignore the packet. If it's lower, then if my revision number is lower than the one I received, now I'm running 10 and I receive a 12, I don't automatically synchronize to the database at that point, which is what a lot of people think. I send something called an advertisement request. We'll talk about the purpose of an advertisement request in a little bit. Okay? So a summary advertisement packet, pretty straightforward. You've got your version, you've got your code, you've got the management domain name, which is going to be padded up to 32 bytes, the configuration revision number, updater identity, timestamp, and you have a digest. If you're running authentication, you'll have a digest. We'll wrap up this lesson by talking about authentication. So we don't send the password in VTP in plain text, even though the password can be configured in plain text. We use an MD5 digest. I'll talk to you guys a little bit about authentication as we wrap up the lesson here. Okay. The followers field. There is inside the update. There's a followers field. It's the. I'm trying to think of which. It's the third field. It's the third byte in the header itself. It's right after the code field, which indicates the type of message. That followers field basically just tells us that this packet is followed by a subset advertisement packet, which is another type of VTP advertisement. The timestamps, that kind of stuff, we don't really care about too much. Like I said, the the message digest 5 field, which is a 16 byte field in 128-bit address, carries the VTP password if the VTP, it carries the hash if the VTP password is configured. I'll demonstrate that a little bit later on. Okay, so that's a summary advertisement. Now we also have something in VTP called a subset advertisement. If I add or delete or change a VLAN in a VTP server, the changes are incremental changes. The configuration revision number is going to increment, and then that switch is going to issue out a summary advertisement. All right. 1 or 2 or 3 or 4 different subset advertisements are going to follow that summary advertisement. Remember, that summary advertisement is going to be sent as a triggered packet, right? Triggered packet. We're not waiting for that 5-minute interval. The subset advertisements are going to contain a list of all the VLAN information. If there are lots and lots of VLANs, then we might send more than one subset advertisement to be able to advertise information about all of the VLANs. All right? It's not really critical for you guys to understand the frame formats and the packet formats, but it's something that maybe you can look up. You'll probably see it in the documentation when you go back and look at VTP in that book, the CCIE book. You'll probably see that information. All right. When does a switch need a VTP advertisement request? In other words, when does a switch actually have to go out and request VTP information? If you reset the switch, obviously when it reboots. If you change the domain name of the switch, it's going to believe that it's participating in a different domain or whatever. And the revision number is going to go to 0, so it's going to need a advertisement request. If the switch receives a summary advertisement with a higher configuration revision number, it's going to send out a summary request. Once the switch gets that not a summary request, an advertisement request. Once the switch gets that advertisement request, then we respond with that summary advertisement and then the subset advertisements that are tied to the summary advertisement to allow us to send out the VTP information. So there are 3 modes of operation within VTP. I'll go ahead and just put some notes here. VTP operations. You've got server mode, which is the default VTP mode of operation. In this mode, we can create, modify, or delete VLANs locally. All right. And we can also change other configuration parameters, like we can change our VTP version, whether or not VTP pruning is turned on or off, and then that will get propagated throughout the entire domain as well. There are certain aspects of the VTP configuration itself that will also propagate throughout the VTP domain. So VTP servers are going to advertise their LAN configuration, their VLAN configuration, to the other switches that are in the same domain. So we send VTP advertisements using that periodic timer or the subset summary advertisements as a triggered process based on a change. So we send VTP messages. We also accept VTP messages. And on top of that, we will synchronize to the domain. So if a server receives a summary advertisement with a higher revision number, that server will synchronize, spell synchronize correctly, a little pet peeve. All right, that server will synchronize to the domain. So servers can update other servers. And clients can actually update servers. Which is kind of a unique concept, because when you think about a VTP client, you think about the kind of server-client architecture in most environments, and the client is kind of passive. Well, yes, it's true that it's unlikely that a client will update a server. If you just happen to plug a client switch into a network that has a higher revision number, as long as it's part of the same domain, it will update the server. Okay? So servers don't distinguish a difference between a client and a server. Okay? Got to outlive your enemies. Oh, nice. I just saw that text message to the group there. All right. So that's basically your server, and we can do this in global configuration mode. We just simply say VTP mode server, which is something you guys are probably familiar with. The next option is client. All right. Now, a client behaves pretty much the same as a server, with only the following exceptions. Okay. You cannot, and I'll just copy this here. You cannot create, modify, or delete VLANs locally. Only through VTP can we create, modify, or delete VLANs. And I demonstrated that when I was showing you the automatic creation of the VLANs themselves. All right. Now, there's another aspect of a client switch that's important to understand, is that client switches don't maintain a copy of VLAN.dat. So if you reboot a client switch, not all aspects of VLAN.dat. If you reboot a client switch, it needs to find a server so that it can synchronize its database before it can become functional. All right. Other than that, clients can update other clients. Clients can update servers. Clients send VTP messages. Clients accept VTP messages. Clients will synchronize to the domain. So outside of the fact that I can't add or delete or modify VLANs locally, a client switch pretty much acts like any other server switch. All right. The next mode that we talk about is transparent mode. Transparent mode, which is actually Cisco's preferred mode of operation for security reasons. Okay? In transparent mode, you can create, modify, and delete VLANs locally. In fact, that is the only way that you can modify or otherwise configure VLANs is locally. Transparent switches do not synchronize to the domain. So they do not sync. Now they can participate in the domain. And I'll demonstrate this in a little bit by passing VTP information along the path. So a lot of people say, well, if I'm going to run my switches in transparent mode, then I don't really need to worry about the domain configuration and whatnot. But if, and it's somewhat true, if the entire domain is transparent, because basically that's effectively you disabling VTP. Okay. But if you've got a transparent switch in line and talking to other switches, then and their clients and servers, then a transparent mode switch would definitely be have to be part of the domain so that it can pass the advertisements. So we don't advertise. We do not advertise or accept VTP messages. All right, because we're not running technically VTP, I guess. We do forward advertisements out of our trunk ports in VTP version 2, not version 1. Now there is another mode. I don't usually talk about it because It's only available in CatOS switches, the off mode. All right. Now, VTP version 3 does give us the capability of turning off VTP, but technically speaking, in version 1 and version 2, unless you're running CatOS, you're not going to have the ability to disable VTP. So the next best thing would be to simply run everything in transparent mode. All right, one more thing before we get into the configuration. VTP version 2, not much different than version 1. Okay? The major difference between VTP version 2 and version 1 is that VTP version 2 introduces support for token ring. There's a couple of other things as well, and I'm trying to think off the top of my head what it is. There's some consistency checks that get added in VTP for version 2, but for the most part, it's just this addition of token ring support. So if you do want to run a token ring VLAN, I have no idea why you would, but if you do want to run a token ring VLAN, you have to run VTP version 2. Otherwise, there's really no reason to run version 2. Changing from version 1 to version 2 is simple, and it does not require a switch reboot. It's a very, very simple process. We're going to talk about authentication and pruning in a little bit, but you can secure VTP by using a password. The passwords themselves have to match on all the switches, and the passwords are case sensitive. In the VTP password that we configure gets translated by an algorithm. In fact, it's an MD5 hash into a 16-byte word that is carried in all of my summary advertisement VTP packets. So if a password is configured, it has to match because that value gets carried. I'm going to show you something else about that a little bit later on. Another thing that we're going to talk about is pruning. VTP pruning is a dynamic way for us to prune VLANs off of particular trunks. If all the switches in the network and the domain are VTP aware, they can run VTP pruning, which allows us to get rid of unnecessary traffic on links and prune off traffic on particular links. We'll talk about that a little bit more as well. All right? By default, our switches are configured as servers. For most small-scale networks, that's fine. It's not a big deal. All the VLAN information gets stored in NVRAM. In a large network, you really have to decide how much storage is necessary. Is that necessary to duplicate that on all the switches and so on, and decide whether or not you want to run server mode or client mode on some of those switches. All right? All right. If a switch is configured as a server without a domain, you can configure a VLAN on the switch, but it just simply won't propagate. It's not going to, it'll go into VLAN.dat, but it's not going to increment the revision number, and it's not going to get propagated throughout the network. If I attach a new switch to the edge of a VTP domain, that new switch will automatically join that domain under two conditions. If the domain name is not set on that new switch, and if you're not using authentication within your domain. So the switch is going to join the very first domain it sees. Let me demonstrate. This will be the first concept that we demonstrate here. All right, so if I do a show VTP status on these switches here, in fact, let me just go ahead and run it on all of my switches. I'll send an end real quick, and I'll do a show VTP status. You can see that the domain name is null on essentially all of my switches here. Null there, it's null here, and it's null here. Okay? So what I'm going to do is I'm going to go ahead and configure VTP, the domain name, on switch 1. All right? First thing I'll do is verify I have trunks, show interface trunk. I can see that I'm trunking. I got some weird stuff going on. Let me go ahead and, I mean, it's not going to really affect us too much, but let me go ahead and fix that. Interface, range, Ethernet. Ethernet 0/0, comma, ETH1. Oh, sorry. Almost be quicker just to do this individually. Ethernet 1/0-1, Ethernet 2/0-1. Switch port trunk allowed, VLANs all. All right. Show interface trunk. Okay, that looks better. All right. So I'm going to come in and I'm going to say, okay, VTP domain, and we'll call it CCIE. So you can see that the domain name changed from null to CCIE. And if I do a show VTP status, do show VTP status, jeez, I can see that the domain name changed to CCIE. If I go back to this switch, I can see that it joined domain CCIE. And this switch joined domain CCIE, and this switch joined domain CCIE. So the devices automatically join the domain. Now, once the domain is set, it can only be manually altered. All right? But because the domain name was not set, and it was a null domain, it automatically joined the first domain we saw, which, by the way, obviously is a big security concern. Because if the default behavior is not to have the domain name set, I could plug a switch into your network. If you're running DTP on an interface, I can make that interface a trunk, and then all I have to do is start generating VTP messages with a domain name, and guess what's going to happen? You're going to join my domain, and I will get a copy of your VLAN database without ever logging into your switch. All right? DTP sends the VTP domain name inside of the DTP packet. So if you have two ends of a link that belong to different domains, the trunk link actually will start screaming. Let me demonstrate that. So we've got in our topology here, Ethernet 2.0 and 2.1 between switch 1 and switch 2. So I'm going to go into switch 2 in this case, and I'm going to change the domain name to CCIE something. Let me see. VTP domain, CCIE, oops. Okay. Now what I should start seeing, now I don't know, we're running ISL in this case. ISL might act a little bit differently, but what I should see is some concerns about, yeah, there we go. All right, that's what I was expecting to see. So not only will DTP report this, but CDP should start going crazy as well. We're seeing unable to perform trunk negotiation on port 1.1 because of a VTP domain mismatch. Okay, which means that the trunk interface is no longer functioning. Show interface trunk. And you can see that 1.1, well, I guess it's still operating as a trunk. That's kind of weird. I might have to bounce those ports to make them. Let me just bounce one. And see if it responds. What should happen is the interface should not really be able to negotiate the trunk process. So show interface trunk. Yeah, so 1.1 is gone now. All right. The other ones had already negotiated everything, so they'll work fine until the process restarts. But because we have a domain name mismatch, these switches are not going to be able to negotiate those trunks. So let me go ahead and change the domain back. VTP domain CCIE. All right. And if I do a show interface trunk, we should see that 1.1 should eventually show up as a trunk here. We'll give it a minute to come up. All right. All right. If you use DTP, you have to configure the trunk mode And you can obviously get rid of DTP. That's the best practice standard. If you, for some reason, don't want the domains to match. I guess my point is that, I mean, whether or not VTP is working or not has no bearing on whether or not the switches work, right? Remember, VTP is purely a management protocol, and the goal of VTP is to simply process and exchange VLAN information dynamically, all right? If you have a domain and that domain has a single VTP server, and for some reason that VTP server crashes, the best and the easiest way to restore the operation is to upgrade or change the operation of one of your VTP clients to server. The revision number won't actually change. It will simply start to function as the server for that particular domain. Okay? All right, so we've gone through some of the basic concepts of VTP. Now, obviously, we want to just kind of take a look at some of the different configurations. It's not really that complex. Obviously, I'm going to talk about some of the characteristics and show you how VTP operates. All right, remember, again, VTP does not define the broadcast domain, okay? It's just used for the administration, not data plane forwarding, all right? We talked about some of the modes. We'll talk about some of the caveats, and I'm going to go ahead and start to do some different configurations here. As I mentioned before, VTP only runs over trunk links, so we need to make sure that our trunk links are working first, part of your layer 2 configuration. The primary verification method in VTP is to do a show VTP status. And we already saw the null domain. So we set up the domain as CCIE. Show VTP status is already confirmed that all the switches joined that domain, inherited that domain automatically. All right. Now, one of the things that I didn't show you is the necessity for these switches to synchronize. So if I do a show, actually, let me do this on all of the switches, and I'll do a show VTP status. You can see for this particular switch, the current revision number is 1. Now let me add a VLAN. VLAN 200, VLAN 201, VLAN 202. Show VTP status. You'll see that as I made 3 changes to the database, and we had 3 revision numbers that occurred. Even though we were only in the database one time, every time we made a modification to that database was updated. So let me do a show VTP status. All right, oops. Show VTP status. Okay, now make a note of this. I know it won't be easy to remember, but hex D5, hex BB. If I go to switch 2, I guess I better just run it this way. Show VTP status. You can see it's hex D5 and hex Bravo Bravo. So the hash matches on all the routers. The hash is a product. It's actually a product of the revision number and the revision number and the password. Okay. Show VTP status, Delta 5 Bravo Bravo. And then finally, show VTP status here, and Delta 5 and Bravo Bravo. So the hash matches, which means that if I receive these advertisements, then I can verify the authenticity of those advertisements because the hashes match. Is it possible for me to receive an advertisement where the hash doesn't match? Absolutely. If I'm on revision 4 and there's another switch on revision 5, and I receive a VTP advertisement, the hash is not going to match because the hash is a product of not only a hash of the password, but it's salted with the configuration revision number. But that's okay. If it doesn't match, we're already going to go through the process of updating the database because of the revision number doesn't match. So we know we need to get a better revision number. Okay. All right. Obviously, the goal here: administration, simple plug-and-play functionality. Really basic configuration. All right. Now, if I configure a switch as a client, all right, if I configure a switch as a client, let's do that on switch 4. Config T, VTP mode client, and I try to add a VLAN. It'll say, of course, I cannot add that VLAN because I'm a client. The client switch can only get VTP advertisements through the VTP process. But if I do a show VTP status, you can see that the configuration revision number still didn't change by changing the mode. All right, unless I go to transparent mode. If I place a switch in transparent mode, then the revision number, in fact, based on our topology, because I want to demonstrate something else here, I'm going to make switch 1 transparent, and switch 3 and switch 2 are already servers, and switch 4 is a client. So I'm going to go ahead and make switch 1 transparent to demonstrate a couple of concepts here. Let me go into switch 1, config T, VTP mode transparent. Now, if I do a show VTP summary, or status, excuse me, thinking of spanning tree. If I do a show VTP status, you'll notice that the hash didn't change, but the revision number did change. Okay? Now, the hash actually doesn't really matter in this case because we're no longer synchronizing to the domain. But the fact that the revision number changed to 0 is pretty significant. I mean, we're transparent switch, so there really isn't the need to have a revision number in this case because I'm not synchronizing to the domain. Okay, so the VTP revision number in transparent mode is always going to be 0. The domain name does matter, though, in a transparent switch, and the domain name is case sensitive. Now, VTP can be disabled in version 3, but it can't be turned off in version 1 or 2. So that's kind of why we run VTP in transparent mode, is to kind of protect that operation, that function. Now let me demonstrate something real quick. We've got this switch operating in transparent mode. Let me do a quick show VLAN on this switch just to confirm what VLANs we have. Let's do a brief. Show VLAN brief. And we can see that we have VLAN 100, 101, 200. I'm gonna work with VLAN 300 in this example here. So I want to go ahead and actually 300 and 301. I'm going to go ahead and go to my server switch, which is switch 2 or switch 3, and I'm going to create VLAN 300. Name, test, trans. Okay. So if I go to switch number 1, and I do, actually let me not do that. Let's go to switch 4 and switch 3. If I do a show VLAN, you can see that VLAN 300 did in fact propagate through the network because that transparent switch forwarded that particular advertisement. All right, and if I go into switch number 4, do show VLAN, I can see this is our client. I can see that even in this switch, that VLAN propagated. Now, if I come in here and I go interface VLAN 300, give it an IP address of 100.0.0.4, 255.255.255.0, and I go into switch number 2 and do the same thing. Interface VLAN 300, IP address 100.0.0.2, 255.255.255.0, and do a no shut. It's already up, but that's okay. You would think that the VLAN exists, right? The VLAN exists on switch 2 and the VLAN exists on switch 4. The VLAN exists on switch 3. So I should be able to ping from the .4 over to the .2. So if I ping, or vice versa. So if I do a ping to 100.0.0.4, that ping is going to fail. I think it's pretty obvious why the ping is failing. Even though the transparent switch propagated the VLAN information, it did not add the VLAN to the transparent switch. Remember, switch 1 is our transparent switch. If I do a show spanning tree VLAN 300, you will see that there is no spanning tree instance for VLAN 300. And because there's no spanning tree instance for VLAN 300, we don't have any forwarding paths for VLAN 300. If I come in here and I do a config T and I add VLAN 300, now I can go back and do my ping, and that ping will work. We just have to go through our ART process. But eventually that ping should go through. Probably waiting for some spanning tree stuff to happen here. But eventually that ping should go through, right? Because VLAN 300 is active. It should be, unless I'm filtering. Let me do a show interface trunk here. Yep, 300 is allowed. It's not allowed across all the ports though. Let me see this one more time. It's not allowed across 01, 00, 11, or 110. I'm on switch 2. We may be running into a situation where spanning tree is blocking specific ports, but it really shouldn't matter, right? Because VLAN 300 does exist in all of these switches. So let's try it one more time. So let me check something real quick and see where spanning tree is forwarding in this particular VLAN. So actually, let me do a show IP interface brief real quick. Make sure I did have the, okay, so it is up, it's in VLAN 300. Show spanning tree, VLAN 300. So it's definitely forwarding on all ports except for port 21. So it's VLAN 300 is forwarding on all of those ports. Let me go into switch number 4. Show IP interface brief. 10100. No, that would be a problem, wouldn't it? Interface VLAN 300. No shut. Forgot to do that. All right. So I should be able to ping 100.0.0.2 in this case. All right. Now spanning tree might still be doing its thing, but eventually that will come up, and it would definitely work in this case. If I do a show spanning tree VLAN 300, I should see, yep, 00 is a root port. Granted, all my other ports are blocking in this case, but 00 is a root port. So the ping should be able to go through unless I forgot to do it on show spanning tree VLAN 300. That one's forwarding as well. This one I didn't put an SVI on, but we shouldn't need that. Okay, so why is it not working now? Are we doing some pruning over here? Let me see. Show interface trunk. Yeah, it's allowed across 00, and this is on switch 4. So it's allowed across port 00, which is this link that goes up to switch 1. Let me see what the forwarding instance is on switch 1 for VLAN 300. Show spanning tree VLAN 300. Well, that's the root. This bridge is the root, so all the ports are in a forwarding state. Huh. And I'm trying to get over to switch 2 from switch 4. So it should be going up here, and then it should be going across here. Interesting. It's not. Let's go back to switch 1, show VLAN. 300 is in the database. Switch 2, show VLAN. 300 is in the database. Show spanning tree VLAN 300. Definitely forwarding. Okay. try one more time. Ping 100.0.0.4. I have a feeling I know what this is related to. I'm going to make a change. I'm going to pause the video real quick and make a quick change. I think I ran into this before with SVIs and GNS3. Give me one. So that's just one of those little annoying things that you run into with GNS3. For some reason, SVIs don't work very well with ISL encapsulation. So I just had to go through and make sure that all of my interfaces were trunking in .1Q so that my pings would go through. All right. Now, just to clarify, I had added VLAN 300 to my transparent switch. So I'm going to take out VLAN 300. All right. Now this ping should fail unless spanning tree is taking a different path, but switch 1 is the root, so it should, even though VLAN 300 doesn't exist on that switch, it should, well, you know what? It's probably going to end up renegotiating the root to be switch 2 or switch 3, but let me do a ping. 0.2. Yeah, so the ping is failing now because it still thinks that it needs to go to switch 1 as the root. If I do a show spanning tree VLAN 300, the root port is 10 for that particular spanning tree, which is the link that goes up to switch 1. But switch 1 doesn't have VLAN 300 in the database. So if I did a show spanning tree VLAN 300 on switch 1, it would show that the VLAN database doesn't exist. I mean, the spanning tree instance is not forwarding in that particular case. All right. In fact, we would then eventually see that more than one switch is going to start to claim to become the root for that particular VLAN because they think that the switch in between is not actually running VLAN 300, which can cause all kinds of problems. All right. If the name doesn't match, you guys can probably stipulate that obviously synchronization is going to be an issue as well. Let me go ahead and add VLAN 300 back into here on switch 1. I'll do my ping one more time. That ping should eventually come up. Spanning tree is doing its thing, but that ping should eventually start working in that VLAN once spanning tree does that. Okay. We already talked about the concept of how if the names don't match between the switches, you're going to start to get some arguments from DTP and some notifications from DTP indicating that there's an issue with the names mismatching on the domains. So if you do a quick show VTP status, and maybe you can even kind of grep it out, include name, pipe, mode, so you can pull out pieces of the configuration. Now use the grep commands in the lab, guys. It's going to save you a lot of time, especially if you're dealing with significant amounts of information that you're trying to filter through. Use those grep commands. All right. All right. This, will you see this in the configuration part of the lab? Probably not. Is there the potential of seeing this in the troubleshooting portion of the lab? Absolutely. You could see VTP-related issues in the troubleshooting portions. Could be a domain name mismatch. It could be that one router is running a password, the other routers are not running a password, and so on. All right? We have 2 more things to talk about in this section, and then we'll wrap it up for tonight. I want to talk to you guys a little bit about authentication first, and then we're going to wrap up by talking about VTP pruning. Now in VTP version 1 and version 2, it's a fairly weak authentication process. You simply set a VTP password and use the VTP password command to do that, and you set the password. All right. Now if I do a show VTP status, you will notice that the hash has now changed based on the fact that I've set the password to CCIE. And I can do a show VTP password to actually see what that password is. The password is case sensitive and it does allow trailing spaces. So make sure you don't accidentally put a trailing space in there. So if I do a show VTP status here, because the hash changed because the revision changed, but because the hash doesn't match, then obviously we're going to have an issue synchronizing the domain. So I'm going to go ahead and set the VTP password, in this case to CCIE. The VTP password is not something that propagates. VTP password CCIE. It has to be manually configured on the devices. And we'll do the same thing here, config T, VTP password CCIE. All right. And now if I do a show VTP status, you can see that the hash value, we'll say 8A and 8 Bravo, should match on all of the switches. 8A and 8 Bravo, and do show VTP status 8A and 8 Bravo. All right. Even on the transparent switch, well, the transparent switch is probably not going to match do show VTP status, because remember, these hash values are not simply created based on the password. They're salted with the actual revision number. Doesn't really matter on the transparent switch though, because we're not synchronizing to the domain, so the hash does not have to match. All right? All right. So the last thing we'll talk about very briefly is VTP pruning. VTP pruning is a dynamic method for pruning VLANs off of a trunk. And the switches will actually communicate with each other to identify to the downlink switch and the uplink switch in both directions what VLANs it needs and what VLANs it doesn't need. All right, now this does not work in transparent mode. You can only run VTP pruning on client and server switches. All right, and the pruning list does not have to be symmetrical. One switch does not have to agree to what VLANs are being pruned with the other switch. Obviously, that's not always the case. All right, but the whole point of VTP pruning is to dynamically prune rather than manually prune VLANs off of our trunks to get rid of those unnecessary broadcasts, unicast frames, and multicast frames that exist. Now you can see here that VTP pruning is disabled by default. All right, now switch 1 is still a transparent switch. So I'm going to go into switch 2, and I'm going to turn on VTP pruning by typing in the VTP pruning command. If I do a show VTP status, you can see that that actually modified my revision number. So that is something that should propagate to the rest of the switches in the environment. And sure enough, I can see that pruning mode is enabled here. We've synchronized to the latest revision number. And do a show VTP pruning status here. We can see pruning was propagated to this switch. If I look at the transparent switch, do show VTP pruning status, excuse me, pruning is disabled. But that makes sense. So I'm going to turn that on my transparent switch. Oh, never mind, can't do it, right? I'm going to talk about that in a little bit. That actually can cause a bit of a problem in our topology. Yeah, you can only run pruning in client and server mode. I forgot that switch was still transparent. Okay? So only supported in client and server mode. VLANs 2 through 1001 are automatically prune eligible. Obviously, those are our configurable VLANs. VLAN 1 can be manually pruned from a trunk link, but it is not prune eligible with the VTP pruning. All right? Now we can create a list called a VLAN pruning eligible list to identify what VLANs are allowed to prune or not prune based on that eligibility list. We use the switch port trunk pruning VLAN command to set that eligible list. I don't think that'll work. Interface Ethernet 2.0, switch port trunk pruning. Oh, it does work here, all right. VLAN, and then I can specify which VLANs are eligible. So it's almost like the VLAN allowed list that we do for manual pruning, but in this case, we're specifying which VLANs are eligible for pruning in the VTP domain. We might decide that our voice VLAN we don't want to ever prune, whether it's manually or VTP, so we would exclude that VLAN from the VTP pruning list, right? Switch port trunk pruning VLAN except 10, if VLAN 10 is my voice VLAN or whatever. I don't know that there's a best practice approach to that, but anyway, okay. If you do a show interface trunk, you can, of course, see which VLANs are being pruned. Let me show you real quick, show interface trunk. This last block here in the show interface trunk output is essentially what VTP is pruning or not pruning, okay? And I'm running that on switch 1. I should probably be on one of the other switches. Do show interface trunk. And you can see it's significantly different on one of these other switches, because now what's happened is VTP has sent messages back and forth indicating which VLANs are active on what trunks and which VLANs are not active on what trunks. And even though we have a whole bunch of VLANs configured in our database, we're no longer sending that traffic over those links because they've been pruned off. Now there's actually a reason why switch 2 looks this way and switch 3 would look this way, but I'll talk about that in a little bit. All right. There's another way to verify how pruning is happening dynamically, and that's a show interface pruning command. Show interface pruning. All right. And this will allow me to identify which VLANs are pruned for lack of request by neighbor. So this would indicate that my neighbor doesn't need those VLANs, and this is what's pruned for lack of request of the neighbor. So these are the VLANs that I've requested to be pruned, not pruned, excuse me, and the top ones, to be pruned, and the top ones are the ones that the neighbor lacked and requesting to be pruned. And this is what I was talking about before. This switch, the neighbor of switch 2, if you look at our topology, the neighbor of switch 2 is technically switch 1. Now, granted, we do have a relationship with switch 4, but if I look at Ethernet 2.0 and 2.1, and I go back to my command line, Ethernet 2.0 and 2.1, it looks like I am getting some pruning messages from that side. All right. Let me do a little bit of cleanup here. I want to try and make this topology as simple as possible so it's easy to understand. So I am going to disable some of these links. I'm going to disable 0001, 10, and 11 on switch 2. All right. So let me do that real quick. Config T interface range Ethernet 00-1 and Ethernet 10-1. We'll just shut those down. All right. So I've disabled these two links that go over to switch 3, and I've disabled these two links that go over to switch 4. The last thing I'm going to do is I'm going to go ahead and disable 2.0 and 2.1 on switch 4. Okay? 2.0 and 2.1 on switch 4. All right, so now we don't have the redundant topology that we had previously. Essentially, the only links that are active are the links from switch 1 to switch 3, switch 1 to switch 2, and then this link here, these diagonal links from switch 1 to switch 4. All right, so the next thing I'm going to do is I am going to delete some of the VLANs in switch 3 and see how that affects my pruning scenario. So if I do a show VLAN, let's just do config T, no VLAN 20, 70-75, 100-101, 200-201, and 300. So all I'm going to have is VLAN 50 and 60. Do show VLAN. So now I actually have VLAN 202. Let me get rid of that as well. No VLAN 202. So now I just have VLAN 50 and 60 on switch 3. All right. Now if I go back to my topology diagram, I want to see what the effect of that is on switch 2 from a pruning perspective. So if I go back to switch 2, and I do a show VLAN pruning, show interface pruning, sorry about that. Let's see if that's reflected in the advertisement. And sure enough, it is, right? We see that in fact, 50 and 60 are the only VLANs that are pruned in this case, right? Not pruned. Should not be pruned. Ethernet 2.0 and 2.1. Yep, so that's coming from here. Let's see in switch 2. Switch 2 is sending 150 and 60. So let's go take a look at... Oh, that makes sense. Yeah, that makes sense actually. These are the VLANs that exist. I was in the wrong switch. These are the VLANs that exist in switch 3. Okay? The only VLANs that actually exist in switch 3. And they're being pruned because I'm not getting a pruning request from my neighbor. Now, if I go to switch 2, if I go back to my topology and go to switch 2, I'll see whether or not those VLANs actually exist in switch 2. And sure enough, they do. In fact, VTP propagated that whole process. So technically speaking, those VLANs exist, but they're being pruned off. If I do a show interface pruning on this side, I can see pruned off for lack of request by neighbor, none on this side. But yet on the other side, on switch 3, we saw that 50 and 60 were being pruned off. So we're starting to see some inconsistencies in how the pruning behavior is working. Why do you think that is? Because we have a transparent switch in between. Now the transparent switch is supposed to be passing information about pruning to the rest of the network. But it can be pretty inconsistent if you're running your switch as a transparent switch. Just something to keep in mind. All right. If I do if I go ahead and make switch 1 a server, config T, VTP mode server, and I do a show VTP status, it should enable the pruning function. It's joined the domain. So if I do a show VLAN, all right, 50 and 60 are there. So now if I do a show interfaces pruning, I see that we do have pruning occurring here, but that's not necessarily a bad thing, right? Remember, just because a VLAN exists in the database doesn't mean that it needs to be forwarding in the domain. If I do a show spanning tree VLAN 50 on this switch, I can see that VLAN 50 is running in the spanning tree domain. But I may not necessarily be generating traffic in that domain, or I might not necessarily need that domain to propagate across the trunk links. So do a show interfaces pruning will show me whether or not VLANs are being pruned off the trunk link or not. Now it's a little confusing in this case because we have so many different links. They're not Ether channel links. They're supposed to be Ether channel links later on. But you can see here that for interface 1.0, which is our topology, in our topology is this link here, 50 and 60 are not being pruned, but they're being pruned on Ethernet 1.1, Ethernet 2, and so on. The reason why that is because you have to look at your show spanning tree for VLAN 50, and you have to identify which interfaces are in a forwarding state, which interfaces are in a blocking state, and so on. So it's not going to be very clean to kind of identify all that at this point. Later on, as we build our topology in more detail, we'll kind of take a look at, that concept. Here's the main thing, though. When it comes to pruning, it's very important that if you do decide to enable VTP pruning, that you're aware of what the possible deleterious effects could be. VLANs could be pruned when the intent is for them not to be pruned. One other thing I'll mention too is you may have, for example, a link that goes over to a server, a VMware server, and that link is going to be a trunk. Well, VTP is a Cisco proprietary protocol, so it's not going to run on that server, which means I'll be sending out VTP pruning messages to the server, but I'm not going to get any VTP pruning responses from the server. My default behavior in that case is to go ahead and allow every VLAN. But not only am I going to allow every VLAN, because that server is going to need every VLAN. Say the server is connected over here off of switch 1. Because that server is going to need every VLAN, switch 1 is then going to report to all of its pruning neighbors that it needs every VLAN. So effectively, by not pruning through VTP that link that goes to the VMware server, I've disabled VTP pruning in my entire layer 2 domain. What would be the solution to that? Make sure you configure manual pruning on the link that goes over to the server. Because manual pruning can still allow me to identify what VLANs are allowed and not allowed on a particular interface. And that way, my VTP pruning changes don't propagate to the rest of the switches in the topology. Those negative VTP messages or those VTP states. All right. Show interface pruning. Yeah, I'm still curious as to why we're getting, I'm requesting that VLAN 1, 50, and 60 are active to my neighbor, but I'm pruning 50 and 60 on all my interfaces except for 0, 1, 1, 1. Let me do this. Show interface status. Show IP interface brief. Yeah, that's the other thing about GNS3. GNS3 doesn't report the data link layer very well. I shut down a bunch of interfaces, so I can remember which ones I shut down. So 0, 0, I did not shut down because that's the link that goes across to switch 4. Okay, that makes sense. 0, 1, I did not shut down, but most likely in those VLANs, it shut down because, actually it would make sense. In spanning tree, switch 1 is the root for all our VLANs because of the MAC address, and because I added it to GNS3 first. So switch 4 will decide what its root port is based on the port priority of the neighbor switch. And port 00 is going to have a lower port priority than port 01. So if I go into switch 4, actually Ethernet 01 should be in a blocking state. So show spanning tree VLAN 50 and port 01 is in a blocking state. So actually it's doing exactly what we thought it would do, right? I'm pruning VLANs 50 and 60. Let me show you why this is showing me this. If I do a show interfaces pruning, I'm pruning VLAN 50 and 60 on these ports because from this switch's perspective, those ports are active. They're in an up state, they're in a forwarding state for the spanning tree instance in the VLAN because this is the root bridge of the entire spanning tree topology. But these ports are not active because they're either shut down on the other side physically or they're shut down logically because of spanning tree. All right. So that actually, not the nuns, the other 50, 60s. The nuns are the active ports in the spanning tree domain. Ethernet 01, Ethernet 11, Ethernet 20, Ethernet 21, those ports are not active. This doesn't really tell me that, but what it's telling me is that I am going to prune off VLAN 50 and 60 on those interfaces because I'm not getting any pruning messages to tell me otherwise from the switches on those interfaces. If that makes sense. Is traffic, Tim asked the question, is traffic being sent from the transparent switch? Can you kind of expand on that question a little bit? I mean, it's not transparent anymore. Let me go ahead and make it transparent again. Go ahead.
No, okay. I guess I missed part of what you were doing then. I was thinking, like, if you had pruning on, but the transparent switch was still sending traffic, it doesn't know not to. I mean, it's still going to prune that, right? even though it's coming from the transparent switch?
Correct.
I was just trying to figure out why we're still getting traffic. If it says it was being pruned over those ports, why we're still seeing traffic being requested.
Well, there's a difference between requesting and receiving, right? Now, if I just made this switch transparent, so if I do a show interface pruning, I think this is what you're referring to, right? Is this idea that requested of neighbor, and it's mentioning all the VLANs here, but if I do a show VTP status, I'm not actually running, I'm in transparent mode, so pruning really shouldn't be running, right?
But if you have the attached switches, the adjacent switches,
yes.
I mean, are they going to be able to, I mean, I wasn't sure if maybe that was screwing this up in GNS3 because that switch was one of the switches was transparent.
No, it actually wouldn't. The reason I misspoke when I was representing the issues because of spanning tree. I didn't mention that obviously there are going to be ports in this topology that are going to be disabled because of spanning tree, and that will affect your pruning behavior if you've got blocking ports in your spanning tree topology. Okay, so that's really why those particular ports were dropping 50 and 60. Now, if I look at VLANs pruned for lack of request by neighbor, this indicates now that I'm not really doing pruning in this case because I'm in transparent mode. Now, here's the question. If I go ahead into switch 2 and I configure a VLAN, all right, let's say I add VLAN 70 on switch 2. Of course, that's going to propagate to the other switches in the topology. VLAN 70 gets added. Now, if I do a show interface pruning, I can see that VLAN 70 is not being pruned. So that tells me, and VLAN 70 was not added to the transparent layer switch because it doesn't synchronize. So what that tells me is that the pruning messages are actually propagating through the transparent switch to the neighboring switches. Does that make sense? So even though the transparent switch is not actually doing the pruning itself, it has the capability of passing those pruning messages onto the other switches in the topology. Okay? Did that answer your question?
Thanks.
All right. I think, yeah, okay. All right. Yeah, like I said, pruning, the worst case about pruning is if you don't combine manual pruning with dynamic pruning or VTP pruning, you can run into a situation where that pruning configuration can completely be undone by the fact that a device does not support pruning. And we're not talking about a transparent switch in this case. We're talking about VMware servers or router on a stick or something like that, where you're not filtering the VLANs off of those particular trunk ports. Okay? So guess what? That is it. That is the end of that lesson. So we'll stop the recording here and then we'll talk a little bit about what the next steps are in this journey.